Hi, this is Mr. Manley. This is a three-variable linear system problem, and we are looking at three equations, three variables. When we solve this system, we will have the solution will be a point with three coordinates, an x, y, and z coordinate. The process, as I'm going to begin it, is with numbering each of these equations. Number them equation 1, 2, and 3. And then I'm going to combine the equations in pairs to eliminate a variable. I will combine the first two equations, 1 and 2, thusly. There's equation 1, and notice I am going to operate upon this so that the x drops out. So I'm going to multiply the second equation by 2. And then, since the x's match, 2x and 2x, I will subtract the second equation from the first, eliminating the x. Therefore, we have 2x minus x is 0x, and then we have 4y minus a negative y, don't forget to subtract still, minus a negative y will give me 8y, and z minus a negative 6z will give me 7z, and then 1 minus 4 is negative 3. Now, I've used equation 1 and equation 2, so I have to use equation 3 in the next pair. And I can choose either 1 or 2. Looking at this, first of all, since I eliminated the x here, whatever equation I combine 3 with, I have to eliminate the x as well. So I'm combining equation 3 with another equation so that I can eliminate the x. And I can see there that's going to be convenient to combine it with 3, but with number 2. But I could combine it with equation number 1 if I chose to. But over here I'm doing 3 and 2, and I'll just transcribe those. And then again, I have an x and an x, so the way to eliminate that will be to subtract. And I've got x minus x is 0, negative 2 minus y is negative 3y, negative 3 minus a negative 1 will give me a negative 2z, and 2 minus a negative 1 will give me 3. Now I'm going to combine these two equations here, and again I'm looking at eliminating one of the variables. I'm going to look at eliminating the y variable here. Eliminating the y variable, I've got 8y and negative 3y. So I need to multiply these equations by a constant so that the y coefficients match up. The first equation, I will multiply by 3, everything, by 3, and the second equation I will multiply everything by 8 so that I'll have a negative 24. So here I've got a 24y, so if I multiply everything by 8 I'll have a negative 23y with that. So multiplying the second equation, I get negative 24y minus 16z equal to 24. Now I'm going to combine these. Notice up here, when I combined these, I subtracted the second equation. Don't have to subtract. Here, I'm going to add because I have a 24, a positive 24, and a negative 24. So if I add these equations, that's going to make the y term drop out. 24 minus 24 is 0, and then 21 plus a negative 16 is really 21 minus 16, right? So that will leave us with 5z. And then negative 9 plus 24 leaves me with 15. And solving for z, I get 3. And that is the first coordinate that I've got for my solution, right? So I know what z is. Let's write that in. Z is 3. Now we want to find x and y. The way that I'm going to do that is by back substitution. I can take this z that I know, knowing that z is equal to 3, and I can substitute for z here, or I can substitute for z here. My choice. And I'm just going to be very clear on what I'm doing. I'm going to say that I'm finding, not z, I found z already. I'm going to find, let's find y. So I'm going to find y. Well, that's what I have to find. So I'm going to go 8y plus 7, and then z is 3. So that's this. I'm making the substitution here. 7 times 3, and equal to negative 3. And then I'll just solve this equation for y. Just skipping ahead through some simple algebra here and getting y equals 3. And I can substitute that in for my y coordinate. And then finally, we will find x. And again, I have my y and z coordinate, and I can plug those in anywhere up here. Your choice. So finding x, I'll plug into the third equation. Into the third equation I'm plugging in. So that'll be x plus the y is negative 3 plus the z is 3 equal to negative 1. And that'll be x is equal to, just a moment, I missed a negative here. You see this, there's minus z. This should be minus 3 there. So let's change that to subtraction. Minus 3. Okay, so x will be equal to 5 in that case, and I can put that in here. Let's understand two things about this. One thing is that this means that if I substitute any of these values into any of these equations, I will get a true statement. And you can check that. You plug in x is 5, y is negative 3, and z is 3. That is going to be equal to 1. Okay? So that's one thing. The other thing is that I want to visually conceptualize what's going on here. Each of these equations is a plane. If I had 2 variables, I would have a line. When I have 3 variables, I have a plane. So these equations, these 3 equations and 3 variables, each of them is a plane. And what's happening here is these planes are intersecting. These 3 planes, if you look at the picture that I have, the 3 planes are intersecting in this single point here. And that's what we're finding. We're finding the single point where 3 planes intersect. Okay, so that's 3 variable linear system, 1 solution. You'll probably want to watch next video, which will be 3 variable linear system with no solution, or possibly infinite solutions, depending on which video you check out.